All right, guys, I told you it was coming. Another example problem without using a graph and only 2 points of interest. The sample and a spiked sample, or just one standard addition, and that was it. So we need to talk about how to solve this type of problem. Up at the top, you're going to see the concentration of copper in brandy is measured by an atomic emission spectrometer, otherwise abbreviated as AE. After measuring the AE signal from pure brandy, a 50 ml aliquot is spiked with 1 ml of a 100 ppm copper standard. The AE signal for the sample was 2.11, and the spiked sample was 6.37. Calculate the concentration of copper in the brandy. So that's it. We can't really make an Excel graph, can we? It just told us that we made one standard, and that was it. And that's all that we got to go by. And off of that one standard and the sample, we should kind of figure out how much was present in the very beginning. This method is not as accurate. It's not as precise, simply because the more points and the more data that you have, the better and closer your number is going to get to the true value. But it will get us in the ballpark figure. It will do us pretty good. At least gives us a general idea of where this is going to be. All right, so like we said before, we have to start with an equation, and it's bracket xi equals the instrument x divided by, on each side, bracket sf, bracket xf, and I of x plus s. So we've got to figure out what goes where. That's the equation. You got to know that equation, right? And when you think about it, it's not really that difficult. Instrument signal of my sample, instrument signal of the sample and the spike, or the standard. Over to the left, that is just the pure sample that was given to me to run. And then down below, that's going to be the spiked version, the sample as well as the standard that I've added. So let's start filling in the numbers. I sub x is the signal of the sample, which was 2.11. I see it right there, 2.11. The Ix plus s, that is the signal from the spike. That's 6.37, or the standard addition. So those two numbers get filled in pretty quick. The x represents what you're looking for. Well, I'm looking for copper here, and I want to know the initial copper concentration of that brandy that was given to me probably before I drank it all. Down at the bottom, what's the concentration of the spike that you did? So this is going to require us to come over to the side, and it looks like we took 1 milliliter of a 100 part per million, and it looks like we've added that 1 milliliter to 50 milliliters of the aliquot. Oh, so you got to be really careful here. We want to know what is the concentration of that. The total volume, though, is 50 plus 1, which is 51, not 50. Did we say we could do these without volumetric flask? We can, as long as we keep track of the volumes that we're using of everything. We don't need volumetric flask. Who cares about those? All right, so 100 times 1 is 100, and that's equal to 51 times x. Well, I need to figure out what my concentration is going to be. So 100 divided by 51, that's equal to 1.96. And that's 1.96 parts per million, right? That's the unit that we've been working in. So 1.96 is going to go there in that spot. All right, well, what about the x sub f? Remember what I told you. Let's not really think about all the theory. Let's just think about how that sample was diluted. We had 50 milliliters, and we took it to a total of 51 milliliters, right? I said that's all that you've got to do. So you just got to kind of think about how this thing was diluted. So 50 divided by 51 is 0.98. So if I wanted to rewrite this in terms of the same variable, 0.98 bracket CUI. And now I have the same variable, x, to solve for. Okay, so a little bit of calculator work now is all that we have left. So 2.11 divided by 6.37, that gives me 0.3312. And then I have all of this garbage over here that I'm going to have to rewrite again. But that's all right. Multiply each side of the equation by the denominator. So bracket CUI equals 0.3312 times 1.96 plus 0.98 bracket CU sub I. And now use the distributive property all the way through. Okay, so 0.3312 times 1.96 equals 0.6492. Plus 0.3312 times 0.98. That gives me 0.3246. Bracket CU sub I. Well, I need to get everything that's the same on the same side of the equation, right? So again, I understand that there is a 1 here out in front, and that 1 is subtracted with 0.3246. So 1 minus 0.3246 equal 0.6754. And that's equal to 0.6492. I divide each side of the equation by 0.6754. So, let me clear that out. 0.6492 divided by 0.6754 equals 0.961. And the unit here, well, that's ppm, so it's going to be ppm there as well. Look at that. That went much faster, right? It took us a little bit of 8 minutes to work out that problem with a little bit of explanation. No graph, no Excel needed. Minimal sample prep work in the laboratory. I'm just relating 2 signals together, and that's about it. And as long as I can know where the numbers are going to be plugged in the proper way, then I'm good to go. The trick, though, is to understand that this x sub f has to be converted into terms of x sub I. And the way that you do that's through dilution, but I'm telling you the shortcut. Take the total that you used, 50 mils in this example, divided by the total that basically was brought to dilution, which was 51 in this example. And whatever number you get there, that's the number that goes in front of the variable that represents the initial. That is the shorthanded way to do the dilution correction there. Then from that point on, it's just all algebra, people. That's all that it is. So you got to be comfortable working out the math. You got to be comfortable about multiplying things over and using the distributive property. And you know, that's something that you might have to work on in addition to understanding how the problem is written. But I think that if you can do these last 2 problems using the setup by hand, I think that you're going to be pretty good when it comes to standard addition problems. All right? Okay, so when you get to the assignments, Good luck on the calculations. I don't think that you'll need them. I've got faith in you. But there's going to be some assignment problems that will require you to use Excel. And there's going to be some example problems that will require this setup. Just strictly full-blown algebra setup with no Excel and no graph needed. So be sure that you feel comfortable solving these problems either way, because they both could happen in a laboratory. You won't see it coming.